My name is Munib, and I'm a staff design verification engineer, and I have more than 10 plus of experience. So this reason of having the session is so that I can answer your SystemVerilog questions. So I think I see a few people joining in, and thank you so much, guys, for joining in. And let me just jump into having some questions with you guys. Hey, you just tell your name
Good morning,
followed
Munib.
by question.
My name is Nancy.
Hey, Nancy.
Yes. So my question is that what is the use of struct?
So you're basically asking what is uh, the usage of struct?
Yes.
Okay. So here's the thing, okay. There are certain things called variables which we have. Now variable is nothing but it's a placeholder for storing some values, right? Now we can have different types or data types, that's what we call. Let's say if it is an int, so this variable will be capable of holding a value which is of integer type, and int is a 32-bit wide, right? So if I consider 0 down to 31, so many bits it can hold. Now, since if we want more number of placeholders and they are trying to hold the similar type of data, so let's say I can have int v1, v2, v3. Now, all of these v1, v2, v3 will be holding integer kind of values, right? So they'll all have 0 to 31 locations, and they're holding the same type of data, which is kind of int type, right? So what we do is, instead of having, defining this multiple times, we would create something like an array, right? So let's say variable array, whether it is fixed, dynamic, or anything else. For now, let's just say that we're using a fixed array. So this is what we have. But now this means that there are 10 locations starting from 0 all the way till 9, and each location is holding the data which is of type int, right? So we have variables, we have arrays. Now where the structure is basically used, it is trying to, you can consider its grouping mechanism, wherein you're trying to hold different types of variables in the same place. So for example, let's say I have your name, right? So in order to declare your name, I need to have, say, string name, and then perhaps you might have a phone number. So I would just say, and maybe I'll put it as int, and I say mobile, and then maybe I would say, what is your percentage? So I might even have like a float, and let's say I say percent. Now, all of these are individual elements, but now let's say if I have to access them, there is no structure to it, right? I need to keep accessing separately. So what do? I group them into one thing and place them into something called struct. So struct is a keyword for defining a data type, which is a group of different types of variables holding different datas, right? So I'm not going into the syntax of how do you write it, but you write a struct and then the name of it, and you close it, right? So now let's say you've given the name as a student. So this is the structure name. So now what will happen is that, just like the way you created the variables here, which of type int, you can go ahead and do the same thing. You can just say student. Let's say I'm writing underscore is. This is a good coding practice to let know that what data type is what. And let's say if I say student underscore s, and say the name of some person, but let's say if I say s1. So I've created it. Now I can even access s1 dot name to be equal to, let's say, Nancy. Similarly, I can do s1 dot mobile to have a value, right? 1, 2, 3, 4, 5, whatever the number is. And then s1 dot percentage. And then I can say 86.5, so on and so forth. So what will happen with this is that all the related data we can group together into one place. So this is all your related data. Now, why this is important is that as things become complicated, we need to group things to make it easier, right? And that is how things would work even in general situations. You group people with either the religion, you group people based on the region that they belong to, the country. So it's easier to refer. Similarly, we have something called struct. Okay, so struct, in conclusion, is a group of different types of variables holding different set of data types, but into one place. On the other hand, arrays will only be holding different elements, but everybody will be holding the same data type value. Does that make sense?
Yes, like my question is about the size. For
Mm-hmm.
example, I will access s1 dot name
Mm-hmm.
Nancy.
Mm-hmm.
After that, I will access mobile number.
Mm-hmm.
So basically, the struct size is the maximum data type size. It will take whatever the data is stored inside the struct. For example, a string, int, and float, which is the maximum size
Mm-hmm.
of data type, it will take that. So
Mm-hmm.
basically, after Nancy, if I want to access that mobile number,
Mm-hmm.
it will override my data in that memory or what?
Okay. So possibly I'll put this as a second question, wherein you're asking the thing related to the size of the struct data type, right? So now the size of int data type is 32 bits, right? That we know. But struct is not that way. Struct will not take the size of struct, will get a little more complicated based on whether it is packed or unpacked. Okay. So I'll not get into that. Considering that this is packed, okay, so I'm writing the keyword here. Considering that it is packed, it is still the sum of the elements that are taking, which means that here we have string, okay, we have int, and we have float. So what will happen is that it will be taking the sum of all. What you are referring that if I use name and then I use mobile, it will override, okay, that is you're referring to union. Union, what happens is that union is similar to struct, but there only one element in that struct could be accessed and the size would be the largest among all. But in a struct, it is a sum of each of the data types. So the float is a separate variable. So I can put it in graphically this way. So every time you have a struct, it will create three different variables, which is or location, we can say name, mobile, and percentage. So the locations or the memory is separate. This is important to understand in case of a struct. But the same thing, if I do it in a union, what happens? The maximum of all will be the only memory, and I can use name, I can use mobile, and I can use percentage to access the same location only. This is union. Does
So
it make
in
sense?
case of in case of union, it will
Mm-hmm.
override the data. Like I say,
Mm-hmm.
by mistake, I use that struct word there.
Okay.
Uh, like it will override. For example,
Mm-hmm.
name I'll access. After that, I'll access mobile number. So in place of name, it will replace mobile number.
That's right. So that's right. So the another way to look at it, think that the name, mobile, and percentage are all different pointers to the same location. So that if I use name, also I'm accessing the same location. And let's say by writing name, I would have written, let's say, Nancy, right? So this place is holding that value. Now, the moment I use mobile, I'm still accessing this location and I can override. So instead of Nancy, I write 1, 2, 3, 4, 5. And then maybe using percentage, I will say 86.5. At the end, whatever was written at the last would win. Okay, so unions are used in those places where the location is same, but any different pointer like this could be able to access that and change its value.
Okay.
Okay.
Thank you.
Sure.
Thank you.
Yeah. So can we have next question? Somebody have a question, you can go ahead and ask. I think there's also a way where you can raise your hands as well in this meet.
Hello.
But yeah,
Hello.
yes, I can hear you. Just tell your name and followed by a question.
Yeah, I'm Mauna. Like, what is the main application of like polymorphism and virtual class, like abstract class?
Okay. So if I understand the question right, you're asking what is the difference between polymorphism and virtual function,
Classes. No, virtual class.
virtual class itself. Okay. What is the difference between polymorphism and virtual class? Okay. So maybe I'll just these are quite different. Okay, so there is not real comparison. So what I would do is that possibly I'll explain this concept and then this concept, and then we will get to know what is the difference between the two, right? So
The difference are the main applications regarding that because it's like quite similar, right? Like,
okay, the applications as well. Okay, cool. So maybe we'll start with first. So the virtual class, right? So I'll just kind of mute you for a while. Okay, this person has joined. Okay. Okay, cool. Just muted people so that it's not much of noise, but you guys can unmute and ask me questions whenever you want. Okay, so what exactly is a virtual class? So in a virtual class, from the name word itself, virtual means it doesn't really exist. Okay, so if I really have to talk, whenever we have a class, it's like a blueprint, and then you create a memory using something called objects. Okay, but now whenever we have something like a virtual class, first thing to know is that we cannot create an object out of it. The reason as is because the name itself is virtual, there is no blueprint. Okay, there is no class as such, so that the object cannot be created in terms of a virtual class. That's the first thing. Now, the second thing that we need to understand with regards to a virtual class is this. A virtual class is used as a starting point for somebody. Okay, so for example, I would say a virtual class and let's say cars. Okay, and then I will write say function. I can say size int a. Now from here, and then I'll say end class. Another point to understand virtual class is that the virtual class will not have any definitions for the functions or methods, you can say. It will only have the declaration. Why? Because the virtual class, it's used as a starting point. So now let's say if you want to derive a class from my virtual class, that because that's the only way you can create an object. So now let's say you'll do class, say BMW extends from cars. Okay, and then whenever you write end class, it is your responsibility, that is this class responsibility, to give the definition for this function. If he can have additional functions too, but this function he should actually give the definition for this. Otherwise, the compiler will throw an error. That is exactly the reason, because the class cars is saying that if you extend anything from me, this should be mandatory. Now, why would we try to do that? Because sometimes we want the user to understand certain things or as a starting point, or to implement that for sure, but continue with it. Now, the BMW might have a different size. If I have an Audi car, I can have a different size to it, but everybody should have a size at the end of the day. Otherwise, this car would not work. In that case, we will always use virtual classes to give us a starting point for them. Okay. Now, where would you use the application with regards to virtual class? Is that whenever you want to, let's say you're the architect of a test bench, and you don't know how each one would implement their functions, but you want one or two functions to be implemented for sure, no matter what. That's when you would create these kind of things to give us a guidance. Okay, rather than leaving somebody in the dark, you're just giving 2 or 3 pointers. That is what the application would be useful for. For example, let's say we start a sequence. Okay, so we can have a base sequence wherein we can have a function where we tell that please define which sequencer you're going to use also. Okay, that could be one of the application for it. So virtual classes, in conclusion, is used as starting point for other classes to derive from and create objects from it. Now, coming to polymorphism, polymorphism means taking different forms based on the context. Okay, so for the polymorphism, we can say that there are two conditions. First thing is that we need to have, let's say, class parent, and let's say I have a function display and end class. Now I have child which extends from parent. Okay, end class. Now you need to understand few things. For polymorphism, you need to have extend. If you're not extending from one class to another, the polymorphism would not work. Okay, why? I would let you know now. Second thing that we need to understand for polymorphism, as I said, it takes different form based on the context. So let's say I do something like this: parent p and p equals new. So basically what I've done, I've created a variable called p, and that is, it's a pointer to the object that we have related to the parent. Great. But now, if I do one more thing, let's say in the next, I'll do it here. So parent p equals new. So p is pointing out to the location now. Similarly, I'll have child c equals new. So again, c is pointing out. Now there is this location which we have inherited from the parent, okay, and it has its own locations as well. So I'm just shading it quite differently. Now each one is a different pointer, right? Now we can make a parent to point to a child. So what does that trying to mean? Is that we can make, say, child. So we have C1 comma C2, let's say. Can do this too. If I do C2 equals P, so the parent is pointing to the child. Okay. So what does this mean is that, or maybe put it as C way as well. Now P is pointing to this location, right? So we had this pointer now, but we override it. So this is reverse. So P equals C1. Okay. So here the variable P was pointing to the parent class. Now here the P is pointing to the child class, but only to this location. So from here, if you understand, the same variable P is acting differently based on the context. That is, this is my first context, and this is my second context. So the same variable P is acting differently. Now, what is polymorphism? This is what is polymorphism, is that the same variable can be used for pointing different locations based on the context. Now, for the polymorphism to still work, we need one more thing, is that we need to make this function as virtual. If we don't do that, what will happen is that the P which is we are pointing will be limited only to this area, because at the end of the day, the P is of type parent, and it will be limited even in the child location to only the parent type itself. So if I do p1.display at this point after this line, it will call only the parent display only. Okay. So in order to avoid this, what we do is we write the keyword called virtual. And here also you would basically be overriding virtual function display, so on and so forth. So now our reason, if I do now p1.display after writing the virtual, okay, that is after virtual, it will be p1.display will basically give me the child display. Okay, so now we have understood when you say polymorphism means the parent P variable or a pointer is used in different contexts. The same pointer could be used for pointing for parent class or for a child class, provided it has been extended. So that is what we call polymorphism. But for polymorphism to work, we need to have a virtual keyword, so that whenever we do p1.display, it is not the parent, but it is the child display to be called. Okay, since I've understood polymorphism, taking care of where is the real application. Okay, so let's understand the application of it in terms of verification. So now what happens, let's say that you are trying to create, there are a lot of classes that you'll be creating inside your test bench, right? And we would want to have a ways for creating it. So now let's say maybe I even have a sequence. Okay, so this is my base sequence class. And then I have a lot of things into this. Now, you will extend this base sequence class. So let's say I have drive 8-bit sequence extends from base sequence, right? Now here I would have a lot of let's say functions also into this. So I'll always create virtual function something. Now here also I will have virtual function something. Okay, now why would I use polymorphism? Okay, so the reason of using polymorphism is that if there would be some kind of code in our test bench where we are using the base sequence. So we would have already created a base sequence b1, and we would be doing b1 say dot, if this is my display, I will say display. So this code is already written, right? This code is already there. But now what am I trying to do? I'm trying to say that let me have this new sequence with the function, with the same function which we are displaying. But now I want this function to be displayed or executed, but now without changing this code. So what would happen is that whenever I'm trying to, let's say this is my another method, I will send the extended sequence value, which is my drive 8-bit seq. So the pointer that I've got for this function method is new, but here I will just do this thing, that is b1 is equal to drive 8-bit seq. So if you see here, I'm not changing this line. This line is kept constant, but only this one I'm trying to change here. Okay. Now another way of optimizing this whole code, which we do generally, whether it's a function or a task, that's I'm writing a method. I will write the type of child variable, and then let's say b1. Okay. And this method is already there, which is we're not changing it, b1.display. So now if you see, b1 is actually the child of it, and then you're connecting. So what you're basically trying to do is you're making a parent point to the child so that this code did not change. Okay, so in summary, I can say that for polymorphism to work, we need to extend from a class and have a virtual keyword mentioned. The practical applications is there that we would have written a lot of code using the parent class itself. So now we don't want to go and keep changing all of that code. So what we just do is that if we want the child functions to be called, we will just assign the parent handle to point to that child and just you execute the same code. That is where we are going to use it. That answer your question, Mona?
Yeah, but the thing is like application level is same, but the thing is we're not able to create handle for a parent in abstract, right?
Mm-hmm.
But when we do like extending, whether it may be an abstract class or a polymorphism, the thing is like child will get execute.
Okay, so you're saying that in case of a virtual class and polymorphism, the child class is getting executed.
Yeah.
Child class is executed. Okay, so this child class, which we have, we create an object to execute it. Okay, but here we are trying to create a object to execute it also, but the methods are quite different. Which I mean is that in terms of a virtual, so you can have a virtual class which can even have a polymorphism, right? Which means that from this virtual class, I extend it, but from here, I can even have another extend and have the keyword virtual here too. So I can have this concept. So I'm trying to understand here one thing is that when you say virtual class and polymorphism are both same, how are they same?
No, like I'm not saying same, but in abstract class,
Hmm.
like we can't able to create handle for a parent,
Correct.
right? That is the difference. Like I'm saying, like other than that, you said like for example, one architecture will be there, they will give some like to extend it and to change it, right?
Correct.
Even in polymorphism, the thing is same. The parent will be same. We can extend that.
Yeah.
The whole thing will be present in a child.
Correct. So there are similarities, okay, if you see it in that way, but quite different. For example, you said that from the parent class, we need to. So this is something that we need to understand that it is saying the need. So from here to here, we have to. So this is a need. So from the parent to child class, extended is a must. There's no other way. But in terms of polymorphism, it is not required, right? You don't have to always try to extend it in order to actually do anything. So parent class can also be used independently in terms of as a class. So the practical applications, if I have to think more in terms of a polymorphism, is that a polymorphism would be used specifically when we have a lot of code which we don't want to keep editing it, right? We just want to use whatever the code of the parent was, but make it to execute for the child as well. In terms of abstract class that we're talking, there is no code for the child parent class at all. There'll only be code related to the child class itself. Okay. So the applications, maybe, whenever we think about that, okay, we have to kind of think polymorphism and virtual class, which one to use when. Okay. So the easier way to think is that virtual class, use it at that places when you want your, let's say if you're team lead and you want other members to follow a particular path. Okay, with a start, you can give a virtual class, but the virtual class itself can never be used. So you can never have a polymorphism on that at all. So, okay, it is just a starting point and they extend from there. Polymorphism is used when you don't want your test bench code to be edited. Okay, you have written a code and you're just telling those people, go ahead and keep writing it, but assign the parent to a child so that we execute the polymorphism to execute the same code, but with different values or maybe different execution of the functions.
Okay.
Cool. Awesome. So just a heads up for people, there are like 3 minutes left. So in case if it gets terminated, please join back with the same link. Okay, cool. So can we have other question?
And one more thing is like in polymorphism, the thing is we'll write virtual, right? For methods.
Correct.
What I have read somewhere is like if we extend it, even that, for example, parent is there, I'll extend one, child one, and with that child one, I'll extend one more. That is child one, extend from like child two. I'll extend it. Then with if we didn't write virtual also, by default it will be virtual. I read somewhere, but I don't know exactly.
No, that is a myth. Okay, so I think this is also a good thing to get it clarified. Is that there is by default the functions or methods whichever we have, they will not be virtual. We need to specifically give virtual because we are choosing should it act like polymorphism or just like a normal thing, right? So we can have a parent extend to a child also, right? But by providing virtual, we are saying that whenever my parent is pointing to a child object, the display of this should not be this, but come and display this. So we are choosing. So to burst the myth, virtual keyword for any function or task is not by default. You have to give it. Okay. And that is why we always say coding, best coding practices is make sure that every function or a method that you have inside your class, make it virtual, whether you use polymorphism or not. The reason is that if the user chooses to use polymorphism, your class should be capable of supporting it. If it doesn't uses polymorphism, that is, doesn't make your parent point to the child, even in that case, he can still use your class as standalone to work.
Yeah. Hi, Moni.
Hi.
Yeah. Firstly, thank you for conducting these sessions. So that will be helpful for everyone.
Sure.
Yeah. My question is like, okay. Okay, fine. So let me consider like I'm in a driver. Okay.
Okay.
So I get some input. So I get the input is of a type string. Okay, so the input get varied every time. So let me say the input is like something like a domain.
Okay.
So first time I get the input as domain 0, second time 1, third time something like 100. I don't know what the input comes, but what my thing is like need to compare the string. So if domain matches to me, I need to pass 0 value to the interface.
Okay. Okay.
Yeah. If it doesn't matches, it need to pass 1 to the interface.
Okay. 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 1 second. I just have to. Yeah. People have mute. Okay. Cool. So trying to get your question. So this is my main reason also to even share you my screens is another thing for you guys is that whenever somebody is asking a question, don't put it in your head. It's very difficult to solve anything. Okay, so it's always put it onto a paper or a digital, whichever it is, but writing it down which solves a problem. So this is my philosophy always. A problem well understood is half solved, right? So from a perspective, as a interviewee or a student or candidate, this is the first skill that you should always have. Okay, so now let me understand a question. There's a driver and there's an input which is a string type, and the string could be anything. So you're saying that if it matches, right, then I need to send the value to the interface as 0.
Correct.
Okay, and if it does not match, let's say no match, then it will send a value 1 to the interface.
Yeah. And the condition is like, I know only one thing, that the string should have domain, not 0, 1, 2, 3 and all. So if it is domain, I need to send it. I mean to drive the signals to the interface.
Okay, so it is saying that if the input, whichever we have, okay, so the
Correct.
input should have something called, it should match with the domain keyword,
Correct.
right? Now it does not really matter what is after that.
Yes, correct.
Okay, does it matter anything before than this?
No.
Okay, so that
No, basically,
I can
basically
have
domain is
some, okay, so I can have something like Chetan domain 0 also, or 101, 102 also. Would this be a match as per your question? Hello, can you hear me?
hello. Can you?
Yeah, I can. Just lost you again. Yeah, I can hear you, Chetan. Can you hear me? Okay, maybe some network issue. Yes,
Hello.
Chetan, I can hear you.
Yeah.
So I was
I'm
asking a
listening.
question. I was asking a question. Chetan domain 012 input, would that be considered as a match?
No, it should not be considered
Okay,
because
so,
the first thing, right? Chetan, that will not be. Yeah, correct.
so it
Now
means
it's fine.
anything starting with domain, but
Correct.
doesn't really matter what's there. So if it matches with this keyword, send a 0. If it does not match, then send a 1. Correct? This is
Correct.
what we want. Okay. Since I've understood the question or the requirement, let's try to see what we could possibly do. Now, one of the first thing that we need to understand is that since we're talking in terms of SystemVerilog or even the UVM concepts, let's say we talk about drivers and all, the input that we're gonna get for the driver is basically through a sequence, right? Okay. Now, since it's a sequence, I'm going to have some transaction which will come to the driver. So now, let's say there is a transaction T X coming as an input to my driver. Okay. And that TX will have some variable. Okay. Let's say name, right? Which is of the string type. And I can store any value into the name, which could be Chetan, domain 0, domain 10, so on and so forth. Now, once the driver gets this value, right? So I think so it is what get next item, get item, right?
Yeah, actually, we can do one thing instead of getting from sequence. Okay, we can keep it in agent or some other component like that. Because
Sure.
if it is particular to driver, so then we need to drive the sequence and take care of that.
Sure. I mean, the input can come in any way. I can even have something called a config DB as well to get it. But then since, the main focus of the question was to check, since we're getting an input, I'm just choosing one of the ways which I'm aware of, right? So now, let's say I have tx.name and I'll have an if condition, right? So I need to have an if condition, tx.name, if it does not. So I'm just writing an algorithm first. Okay, this is not a syntax properly.
Okay.
If it is not equal to, let's say, the keyword domain, then I need to basically send. So I will have an interface handle already. Okay, so interface dot let's say em. I'm gonna drive with non-blocking assignment a value 1 based on your requirement. Else, or maybe I'll just put it in this way. It should match, then I'm driving a 0. Else, intf.m will be driven 1. Is my algorithm right?
No, it's not right.
Just algorithm. That is, if it is not, if it's algorithm domain, it is 0 and 1. Okay. Now let's focus on this part. So the main intention of this question is that how would you use SystemVerilog constructs to do this matching? Okay. So what I'm trying to do here is take a problem, break it down so that we actually get to the main point of it. So our job right now with this discussion is to make sure how could we do this. Now, what am I going to do here is I'll try to go into here and tell you, since it's related to the strings, we need to use string methods in SystemVerilog. Okay, let's try to see what are the methods that are available for us to use. Equality, comparison, and there should be a match method. So I'm just trying to see what and all we have in our repository to see. So these are all the methods that are available for us, Chetan. Okay. One of the method that you see is that you compare string 1 with string 2, right? So you know now that there is a equality method, inequality, so on and so forth. This is my knowledge, right? Now, from the specification that you gave it to me, what is the best method that I can use for that particular case is what the whole question is about. So from my understanding, I can use something called strings sub this one. So let me just do this. Let me just do copy and go back to this place. So this is what I feel I can use it. I'll tell you the reasons. What is this trying to tell? It's saying strings. You're trying to get a new string, which is a substring formed by the actual string, right? So let's say my tx.name is a string, right? It can have a lot of characters, doesn't really matter. But you gave me one good hint. That's why I asked, and we need to ask questions. You said that it should always start with this keyword only, but doesn't really matter what's there. So I know that the domain is basically 6 characters that you told me. So now what I will do is I will basically try to do whatever the input that I have, starting from the first 6 characters, right? That is I equals 0, 1, 2, 3, 4, 5. From the actual string, I need to get the small string, which is the subtract of that. So what I will do is I will just create a new string, local string called string compare CMP. CMP is equal to tx dot name. I means from where do you want to start, right? I want to start at the location 0, but
0,
it is saying in position J through J, right? That means there are 2 indexes. So I need to start from 0 through J means should we include 5, right? So now I have got compare as the first this word. Now I can use this if CMP is equal to domain. Getting it?
Correct. Yeah.
Okay.
Got it.
This is what the whole question is about, that given a string, what can you do to do this? From the given methods that I went through, that is why you need to know what are the methods available. From this was the thing that was available. Okay. And this is the best we could use our logic. Okay. One more follow-up question is that, what if we don't want anything related to, let's say, whether it should be case insensitive or case sensitive, right? So whether that means that it if the input is DOMAIN, should that be a match or not match? Let's say if they ask you another question as a subsequent question, what you could possibly try to do, instead of using this equal to, you can possibly do this. Say if you have this method, right? String compare, I compare with S. So you can compare one string with another string. So you can just do, let me use this, cmp dot I compare with domain. So what we are trying to say here is that the CMP, which is a subset of 6 characters, can be whether capital or lower domain, but it should be matching with the domain itself. Does that answer your question, Chetan?
Yeah, Moni. Yeah, there are quite possible ways for this. But one of the thing which I am looking is like by how to utilize the UVM rematch. So yeah, that is also one of the possible fix. But
UVM rematch. Okay, that's something good for us to brew upon, and maybe we can take it, this discussion. But let me just go in a round robin fashion. Whoever have raised their hands, right? I'll consider this as another question, but something for us to brew upon as well. But yes, since you as an interviewer did not give any constraint as you should use UVM or SystemVerilog, whatever. So I used whatever was available for me, right? But if this could be another question saying that do the same thing now using UVM concepts, then we have another interview question to handle. But good one.
Yeah,
Okay,
sure.
so let's go with the next person, Mahadev, who has raised his hand. Yes, Mahadev.
Yeah, yes, Munib.
Go ahead, tell me the question.
Actually, my doubt is in semaphore concept, like how that get and put method will be working in that practical example. Can you go ahead and explain that semaphore concept?
Okay, cool. So that's a very good question. So what exactly is semaphores, right? Now, semaphore is it's like a key concept. Okay, so that is the simplest way I can put it across. Just like the way we are trying to have this conversation on a Zoom call, right? If you, as Mahadev, and I both start to talk, then there's a lot of corruption of data. Or maybe this is a resource. Google Zoom Meet is a resource, and only one of us can access it at a time. So how would we understand that? So what we do in semaphore, that is where the semaphore is basically used. It is that it is creation of the keys, and whoever has the key can use a resource. Okay, so possibly let's try to go and check what we have here in semaphores. Okay, now if you really see, we have functions here. That means it is trying to tell what is the key count. So it is basically a way where we can actually create number of keys. Okay, so semaphore itself is a concept like the keys concept. So it is not the resource. Resource is a Zoom call, but who will access Zoom call? In order to know that, we are creating a bucket where we can have all the keys kept. Okay, so there's a syntax. If you really see here, we have a semaphore key, so on and so forth, right? So what I'm gonna do is, let me just take a snapshot of this. Be easier for me to explain. And go. Okay, so here is my semaphore. Now, semaphore is basically, when we say concept, it's basically a built-in class. Okay, now what we're trying to do? Since it's a class, we need to create the memory for it, which are doing new. And we're saying one. What does that one means? That we are creating a bucket, which we are calling it as key here, and we are storing only one key into this. Okay, it's not a variable or a value one. We're just saying this is the number of keys that are present into this. Okay, so there's only one key. So what I can do is I can even draw a kind of key that we have. Okay, so there's only one key. Now, what we are trying to say is that in this fork join none, we are saying that we have two threads. Okay, and the third thread is after starting with 25. So, but basically A and B are starting at the same time. So we have a thread T1, which we are calling as A, and there's a thread T2, which is calling as B. Both are starting at the same simulation time as per this code. Now, what is the threads? Let's understand here. Now here we are trying to say that we are calling this function, say get one, get room, right? This is getting executed first, and then this gets executed at 5 nanoseconds. That's what the timing says, and this gets executed 0. So it's saying get one. So what is that get one? It is basically saying key dot get of 1. So this is another method in the semaphore key. What is saying that go and get that key, and how many keys? One key it is saying. In a bucket of 1, go ahead and get one key itself. So now, since the thread 1A got executed first, he will go to the semaphore and try to access that key. So now he is gonna go and get that key. So if I can copy paste this part of it and delete the other section. Okay, so now T1.A has the key. The moment T1.A has the key, now there is no key inside this bucket, right? So the bucket is free of buckets. So now, even if this thread goes and accesses the same bucket, there's no key, and this will be blocked until somebody puts back the key. So this is how we are trying to handle multiple threads in SystemVerilog, or multiple ways, wherein that if two people want to access certain thing, what is the resource we are trying to access here? The resource is that two tasks want to execute something, but we are making sure only one gets executed at a given point. So we are managing how multiple threads should be handled. So the simple concept is that whoever has the key, this is what is calling a semaphore right now, is gonna get unblocked. So now, since this guy at 0 has got the key, this has got unblocked, and at 20 it is trying to do put room. Okay, so now let's say the thread A has at the rate 0, and at the rate 20 it is putting back the key. This, on the other hand, is at 5 and at 10. So at 5 it is trying to get the key, right? And it is saying get me 2 keys. Well, the bucket itself right now is empty because there's only one key, and you're trying to access 2 keys, doesn't really, because there's no keys at all. So what would happen is that this will be blocked. Since it is blocked, you can't do anything until this person puts it back. So this guy puts it back only at 20. So you can do any work between 0 to 20, right? You can execute certain tasks, you can create objects, whatever, but then you're putting back the key here. So I'll just do the copy. Paste. So you have done here. So the moment you do here, it will go and get reflected in this part also. Now, this one has executed at 20, finished it. This will get unblocked. So even though it started at 5, it will get unblocked at 20 itself. So at 20, this key we are gonna get, and from there's another 10 nanosecond that we need to consume, right? It is saying #5 and after #10. So at 30, we are basically gonna put back 2 keys. But now you need to understand that when you're saying put room 2, we only had taken only one key. So it is just like trying to tell, even though you took one key, put back 2 keys, you can still do that. Okay, so let's say at the end of the day, it is putting back one more key. So
Okay.
the concept of semaphore in a conclusion, which I can tell you, is a way to handle multiple threads by giving a concept called keys. So in a bucket, we should always focus on bucket. Semaphore is a bucket where we can define number of keys to have. We can even start with one key, multiple keys, we can get 1 keys, 2 keys, how much ever key, and put back how much ever keys also we want. This is a very good example. But how many keys you want to get, if there are no number of keys present in the bucket, that particular thread will be blocked. But you can put back many keys also than you have taken. Yes.
Okay. As you said, like using that put method, we can increase that key
That's right.
sizes also.
That's right.
Okay.
Right. So as you see in this example, we started with one key in the bucket, but once he puts 2 keys, now we have 2 keys now. Okay.
Yes.
Now what would happen is that in the next iteration, they don't have an iteration here right now, but if I repeat this whole thing, this guy will only need 1 key, right? Task here requires 1 key.
Yes.
Okay. But if I have another thread which requires 1 key itself, both are gonna get the keys. Correct? So that is where you should be very careful about how many keys you're gonna get put, or how many keys you're gonna get as well. So semaphore is not only like a lock which has only 1 key, right? It is a lock which has multiple keys, and anybody who takes 1 key can also put more number of keys. Doesn't really matter.
Yeah.
Okay, so this is a very good question and a typical example where we show that even though they are 2 threads, person A, person B, we can create blocking systems irrespective of them, right? See, if I have to execute the same logic using without semaphore, I have to use events, which means I need to create an event, trigger event, and wait in this, right? But now what is happening? There is a code dependency between thread A and thread B. Would you agree with me?
Yes. Yes, man.
Okay. So that is the limitation of events. The same thing we could do with events, but the problem is that the code of each thread has to be dependent on one. That means I need to trigger it from here, and then I need to wait here. In order to avoid these kind of code dependencies, we can just have semaphore concepts. So this is another practical application for you guys.
Okay.
Cool. Okay.
Thank you, Munib.
Sure. Now, anybody else have question?
Hi, Manu. Yes, I have one more question.
Sure, go ahead.
Like dollar casting. Dollar cast we'll use mostly in our like virtual sequencer topic. Also, we are doing dollar casting.
Okay. So you want to understand what does dollar cast mean?
Like we know, like in polymorphism, we can assign child handle to parent handle. But if I want to assign parent to child, I should use typecast.
Okay.
That is the way. But if will comes into UVM, here we are using like UVM sequence base has a by default one handle, that is M sequencer.
Okay. Okay.
And that like which sequencers we will write in that we can default handle is P sequencer.
Okay. Okay.
After that, they are doing dollar cast between like in virtual sequence topic. They are using dollar cast. Like we are not using UVM sequence base in that, but still they are doing dollar cast between the P sequencer, comma M sequencer.
Okay. Okay. So if I understand your question, you're asking, there are multiple questions out here. So I'm trying to see which one to go first. So you're asking why are we using $& cast with P sequencer and M sequencer, or you're asking why do you use $& cast whenever we are trying to assign parent with child?
Yeah, like according to me, if we'll talk about like M sequencer comes into picture when we'll talk about UVM sequencer base class. Because that is the parent of UVM sequencer. So in my code, I'm not writing anywhere like I'm not extending any class from UVM sequencer base.
Right.
Without that also, we are doing dollar cast between my that handle. Basically, we are giving their P sequencer, comma like M sequencer. So my question is, without that, why M sequencer comes into picture?
Okay. Sure. Then so then that becomes a different question. So you're asking question related to M sequencer and P sequencer, and why a $ cast is used there.
Yes.
So $ cast of M sequencer comma P sequencer. Is this the syntax?
No, like P sequencer comma M sequencer.
Okay. Okay.
In theoretical, it's like we will do casting when the type of the class is not same.
Okay.
Basically, that is the way.
So there's little more to that. Okay. So what happens is that now you know that we can do P equals C, right? This is allowed.
Yes.
But when it is allowed, provided the child C has extended from parent,
Yes.
then only this will be allowed. Otherwise, it will throw an error.
Yes.
Correct. In order to check that, we will do $ casting. We will just say C comma P. What it is saying that make P to assign to C only if it is compatible. Otherwise, throw an error. This is a better way to do it.
Okay.
Okay. So $cast act like a defense mechanism for us, wherein that if the child has extended from the parent, only you assign parent with child. Otherwise, we cannot do that. Okay, so that is what we use $cast whenever we want to do polymorphisms and things like that. Now, coming to your question is that why are we using $cast for P sequence, M sequencer when we are not really extending anything from anywhere? Okay,
Yes,
so you need to understand this, that whenever you create a a sequence which extends from the base sequence, UVM base sequence, it already has something called M sequencer inside, okay, which is extending from a sequencer class. So now you can think that this is a parent, right? This is a parent, okay, and then the M sequencer is basically the P1 for this whole thing, which is always there. You don't have to do anything. It's already in the this thing. So whenever you extend your sequence, you extend from the base sequence only, right? So M sequence is coming for you. Now, whenever you start your custom sequence.start on any sequencer, so what will happen is that this sequencer is actually will be considered as a P sequencer because it's a custom sequencer, right? So now this sequencer will always be coming from some other sequencer, right? So let's say this sequencer is SPI sequencer. Okay, now whenever you create the sequencer, what you do, you will basically create a sequencer always. So let's say this will also be extending from the base class, right, of UVM sequencer. So if you really see the M sequencer and this custom sequencer P sequencer, both have somewhere the same UVM base class.
Yes.
Okay, now since they have the same base class which are extending, what we are trying to tell is that there's a lot of code where we use M sequencer. M sequencer is just a sequencer extending, right? And if you really see, since it's coming from here, this is the flow that you go through. That is your M sequence, P sequence is extending from a base class, which is same thing as M sequencer itself. So there's a lot of code in your UVM base library, which we are using M sequencer. So what we are saying is that now, whenever we are trying to do this $cast of this, we are saying that, hey, wherever the M sequencer was used in the UVM classes or in the base classes, don't just use any dummy M sequencer, use a P sequencer, which we are giving to you. And in order to assign parent to the child, which is M sequencer, pointing to the P sequencer and the P sequencer pointing to SPI sequencer would be done, provided that they're extended. So internally, when you say that you have not done anything, it is because it is done inside your UVM classes, wherever you extend, right? there it is doing a lot of extending. And that is why our job is to only do this part of it, because somewhere they are extending it. And if we do this, we'll be able to access. But another point is that in order to use a P sequencer, you need to use a macro in your class. So whenever you are creating a sequence, you need to mention what kind of a sequence is your P sequencer. So that is where you'll be mentioning this guy also. So there are two conditions to use a P sequencer.
Okay.
Okay, cool. Okay, so maybe we can just wind up with a topic which I feel is just coming to my mind right now, is the word unique, right? So there could be a question like, okay, how would you write a constraint to generate a unique value, not for arrays, okay, but a unique value between two variables? So that means, let's say there is a variable 1, okay, and variable 2. So let me just write it like bit 3 down to 0, v1, and let's say bit 4 down to 0, v2, right? So now I want to write a constraint such that v1 and v2 are both unique. So firstly, I need to write rand, because they are, I need to write a constraint and they need to be randomized variables. But at the same time, what we are asking here is that it is trying to create a dependency. That means create any value for v1 and v2, doesn't really matter, but they should not be unique. Okay, what does that mean is that we need to create a dependency now using a constraint. So we know that what is the keyword unique? Unique is used for creating unique values, but between what and what? So now this is a very good use case wherein we're going to write constraint, let's say unique underscore c, the name of the constraints. Now all we need to do is I need to do something called unique, and then I have to do v1 comma v2. So what does this trying to say is that randomize v1 and v2, but make sure that v1 and v2 will not be equal. This is the power of unique keyword. Now, can you do the same thing without a unique keyword? Of course, you could do that. So you can write constraint unique c1. You can just say v1 is not equal to v2, right? It's simple. So then the question would be like, if I'm able to generate a very simple constraint, what is the use of unique keyword? Because this is limited to variables. So now let's say instead of v1, v2, I have v1, v2, v3, v4, v5, so on till v7. Now I want everybody to have a value, but each one should not be same with each other. Now, if I write using this method, then it is very complicated. v1 should not be equal to v2, v2 should not be equal to v3. Okay, but like that, I need to keep writing so many lines of code. But here, on the other hand, it is very simple. All you need to do is just one single line. So unique underscore c, same thing. I write the keyword unique. I'm writing v1, v2, v3, v4, v5, v6, v7. You see how much of compact the code is right now. It is doing the same thing, that instead of writing so many lines of code to achieve the same thing, we are just saying unique with this. Okay, now this is some very use cases which I tend to use, where whenever I need 2 or 3 variables, I can just create this kind of a system. Okay, now they don't even have to be of the same data type as well, right? It could be different too, but I want you to really give this a try with different data types like 3 down to 4 down to c, and see is it really generating those values, and that's very important. So maybe this could be one topic maybe to leave you guys today, so that you have something to brew upon.